the roots of the equation. We will talk about the roots, which are also known as the zeros. Anyone have an idea of what the roots of a quadratic equation are? Anyone?
Like the square root? Is that what you mean?
Well, a square root is a root, yes. How about, we use the term zero as well. Any idea why it might be called a zero? Aaron?
Is it because of the x and y axis?
Yes. So, let's think for a second. We have these different equations. And what we're talking about when we have a quadratic equation, if we were to draw the graph on an xy coordinate plane,
What are roots?
the roots are where your equation crosses the x-axis. Okay? So a quadratic equation is going to look like some version of this. It might look like this. It might look like this. You can have an inverse that looks like this, but it will cross, with one exception, it will cross in two places. Okay, so you'll have two roots. Sometimes the root is the same if it does this. You will have one root. Actually, you have two roots, but it's the same root. Anyways, so we're going to solve for that. So now that I've drawn all this up here, we have x, y. It's called the zeros because we're looking for where y equals 0. Okay? So let's take a look at these that Emily set up here for us. We have x times x plus 3. And we want to know when it equals 0. Okay. So now, let's backtrack a little bit and talk about division for just a moment. What is 7 divided by 7? 1. What is 5 divided by 5? 1. Noticing a theme here. X divided by x? 1. Are you sure?
No.
X.
Okay.
1.
Honest answer.
1.
Do we need to know what x is?
Not a
You're shaking your head no.
Anything divided by itself is 1.
Yes! And if I had candy from back there, we could took this candy off there. Good job. Yes. Anything divided by itself is 1. How about this one now? We're going to throw a little wrench into it.
0, 0.
What's 0 divided by 5?
0.
0. 0 divided by x?
0.
Is 0 as long as x is not 0. We can't do this. That is bad. We can't do this. X divided by 0? No, we can't divide by 0. Bad things happen when you try that. So,
Black hole.
What's that?
Like the gas particle.
Yeah, like, giant creatures come from another dimension, things like that. So, anyways, we're going to find the times when this equation will equal 0. So we have two options. We have two x's we need to solve for, right? So, which one do you want to solve for first? You want to solve for this x or this x?
Parentheses first.
The parentheses first.
Order
Okay.
of operations.
All right. So, we're going to divide this one by x. And we have to do it to both sides, right? One of the fundamentals of mathematics. If you do it on one side, you got to do it on the other. You now understand all of accounting, believe it or not. So x divided by x is 1. So that goes away. 0 divided by x?
0.
0. So now we have x plus 3 equals 0. And I have a really crappy pen. So x plus 3. We still need to figure out what x is. How do we do it?
Subtract 3.
Negative
You need to
3.
move the 3 to the other side.
Move the 3 to the other side. How do we do that, Danielle?
Subtract 3 and make it negative.
Subtract 3 from each side. Then we have x equals minus 3. Pretty great stuff, right? You can't wait to go home and tell your parents you can do this, right? Yes.
Does that mean that both of those x's are minus 3 or just the first one we did?
Just the first one. Glad you asked. Because, like I said, you don't just get one x, you get 2. One equation, 2 x's. So, how do you think we're going to get our other x?
Without answering the first equation. Put the minus 3 in. For the
Into
x that
this
it's
one?
representing.
Into this one?
Yeah.
Okay, let's do that.
But then it becomes 0.
If we have x
Confusing.
times minus 3 plus 3, now I know you guys can't see what I'm writing. Okay, so what's minus 3 plus 3?
0.
0. Now we have x times 0 equals 0, because anything times 0 is 0. But we haven't figured out what the other x is yet, have we?
But it doesn't matter if you're multiplying it by 0, it's 0, right?
Right, but we haven't actually solved for it. This was going to frustrate the heck out of you when you see the final answer. Okay, we're going to use the same process. Okay, let's come back to no eraser. Okay, so we have x times x plus 3 equals 0. So the first time we got rid of this x, right? Let's get rid of the parentheses this time. We divide each side by x plus 3. All right? These cancel out because they equal 1. This becomes
0.
so x equals
0.
0. I said this answer is really going to annoy you because the answer was 0, but you took it wrong.
I guessed instead of figuring it.
Well, no, you took a good stab at it. You said, I think it might be this. I'll give it a try. It wasn't the right strategy, but you picked a strategy. Ironically enough, he gave you the right answer. So you got to be careful about that sometimes. Sometimes you can get the right answer the wrong way, and it can lead you down a bad road.
But had she worked it out, had she done it backwards like Miss Grantham did, would it have worked?
I'm not following you.
He did. I think he did work it out her way down there, and he just got
Right.
x times 0 equals 0, which didn't leave us with what x was.
Okay.
Really was going to be. Yeah.
What's that?
Like each 0 into the original equation.
Oh, back to, yeah, okay, so we can go back and put the original, go back to our original equation, and we have 0 squared plus 3 times 0, 0 times 0, 0, 3 times 0 equals 0. Yes,
Okay, so this may be an obvious question to you.
okay.
Why, if the x in x plus 3, if that one equals minus 3, and the other one is 0, why are there two x's if they're two different values? Why is it an x and something else so that we know that they're different and not the same? You can't substitute one solved x for the other x.
That's a good question.
Because,
Now I'm confused again.
See? Welcome to my world.
Just plug negative 3 into the original equation.
Because they're hitting.
here's what's happening, is we have our xy coordinates, right? Okay, when x equals 3, sorry, negative 3, right? If I put it back in here, what's negative 3 squared plus 3 times negative 3? What's negative 3 squared? 9. What's 3 times negative 3?
Negative 9.
Negative
So
9.
0.
So 9 plus negative 9, yes, equals 0. Because what we're identifying is that 0, 0, and 0 and negative 3 and 0 and 0, 0. The graph of this equation does something like that. So what we've identified is the 2 points where this graph crosses the x-axis. I'm going to get burned at the stake afterwards. This heresy of which I speak. So let's try it with this one. We've got 2x times x plus 5. So we're going to come over to this wall. 2x.
What do we erase?
It's all set to black. Yeah, go get rid of all that. Okay, so which one do you want to solve for first? The 2x or the x plus 5?
2x.
2x! All right. So we are going to divide all of this by x plus 5. All right. So what do we have on this side?
2x.
Cancel out, we have 2x.
Plus 0.
On this side,
0.
0.
So X is.
Okay, we still need to isolate this x. What do we do to this x?
Divide by 2.
Divide by 2. So we gotta divide 0 by 2. So those cancel out, right?
Right.
We have x equals
0.
0.
Is x always gonna equal 0 as long as there's not that extra integer on the end of the equation? One of the x's will always equal 0.
Well, if you have just these, sometimes you will still have zeros even if you have the integer on the end.
Okay.
But yes, anytime you have an x isolated like this, one of your zeros will be 0.
One of your x's will be 0.
Sorry,
Yeah.
your x will be 0.
Because
Yeah.
the integer, I think I remember, is like where it's shifted, vaguely.
Sort of.
Like sort of coming back.
Yeah. All right, so now let's do 2x, x plus 5 equals 0. Another crappy marker. And we're going to solve for the x plus 5. Am I right so far here?
Yes.
All right. So those two cancel, yes?
Yes.
So we have
Negative.
x plus 5. Shh, don't give away the ending. Come on, read the whole story.
Minus 5. Minus 5.
Negative 5.
Negative 5.
Okay, you guys are getting demerits for yelling at answers like that. We got to solve the problem. Yes, so here we have our two zeros are x equals 0 and x equals minus 5. So again,
Do we say minus 5 or negative 5?
She was saying minus 5.
I generally say minus 5. There's going to be at some point in college, you're going to run into that uber math professor who's like, yeah, it's not minus 5, it's negative 5. Get out of here, you heathens. And yeah, you're going to want to drop that class, take it from their instructor. And so you have something like that happening there with that equation. So now, if we were going to go forward with the lesson, what we would do next is we would go to you and say, all right, now you guys need to pair up, and you guys are going to write your own quadratic equation and factor it. And then you're going to make, each of you make your own, you hand it to your partner, they've got to factor it, you've got to error check it, the whole 9 yards. And then I would go do some more examples, and I would do things like this. Walk around looking for a marker. I would say things like, all right, so I have x squared plus 4x. All right, I want to factor this out. This is going to be 2x times x plus 4.
Wrong.
What? What's wrong?
You're multiplying.
There's not a 2 in both terms.
There's not a 2 in both terms. Yes. There's not a 2 in both terms. So I would provide both ones that are correct, but I would also give you some examples of things you can do wrong. Because while it's good to give you examples of how to do it right, it's also to show you examples of how people commonly make mistakes so that you can recognize, oh, I'm going down the wrong road. So we do that, and we would end with an exit ticket where you would talk about what you learned today. So, how do you guys feel about quadratics? Factoring quadratics and finding zeros. We good, not good? All right, we got a little bit to work with, a little bit of work to do, but I think on the whole, we're in pretty good shape.
Is this better than how I felt before the lesson? Before the lesson, I felt like this.
Yeah.
And now
That is
I-
an improvement,
and now I
and
feel like
that
this.
is what we were
So it's an
striving
improvement.
for.
Yeah.
Improvement is good.
Yeah.
So,
Very
that's
good.
our lesson. Thank you.